A single collision in orbit could trigger a chain reaction so severe that humanity might be trapped beneath a shell of shattered debris for generations. The Kessler Syndrome is a theoretical scenario first proposed by NASA scientist Donald Kessler in 1978. It describes a chain reaction where collisions between objects in orbit generate debris that causes further collisions. Each collision creates hundreds or thousands of smaller fragments, each capable of causing additional collisions. Kessler warned that beyond a critical density threshold, this cascade could become self-sustaining and unstoppable. Currently, there are millions of pieces of debris orbiting Earth, ranging from paint flecks to entire dead satellites. Even tiny paint flecks can cause serious damage due to the extreme velocities involved in orbital collisions. Objects in low Earth orbit travel at approximately 28,000 kilometers per hour. At these speeds, even a small bolt or fragment carries the destructive force of a hand grenade upon impact. NASA tracks over 30,000 objects larger than 10 centimeters using ground-based radar systems. However, scientists estimate there are over 100 million smaller fragments too tiny to track individually. The International Space Station regularly performs evasive maneuvers to avoid predicted collisions with tracked debris. In some cases, astronauts must shelter in escape capsules when debris approaches too quickly to maneuver away safely. In 2009, two satellites, one active and one defunct, collided accidentally in orbit for the first time in history. This collision between Iridium-33 and the defunct Cosmos 2251 created over 2,000 pieces of trackable debris. In 2007, China intentionally destroyed one of its own satellites in an anti-satellite missile test. That single test created more than 3,000 pieces of trackable debris, significantly worsening the orbital environment. Russia conducted a similar anti-satellite test in 2021, forcing astronauts aboard the ISS to shelter for safety. These intentional destructive tests are now widely criticized by the international space community for creating unnecessary hazards. The rapid growth of satellite megaconstellations has dramatically increased concerns about future collision risks. Companies like SpaceX have launched thousands of Starlink satellites, with plans for tens of thousands more. More satellites in orbit mean more potential collision pairs, increasing the statistical likelihood of accidents over time. Some regions of low Earth orbit are already considered densely populated, requiring careful traffic management. Space agencies and companies now use sophisticated software to predict and avoid potential collisions in advance. Despite these efforts, near-miss warnings between objects in orbit occur on a near-daily basis worldwide. A full-scale Kessler Syndrome event could render certain orbital altitudes completely unusable for decades or longer. This could severely disrupt GPS navigation, weather forecasting, telecommunications, and scientific research satellites. Modern society depends heavily on satellites for banking transactions, internet access, and emergency communications. A severe debris cascade could effectively cut off humanity's practical access to certain regions of space entirely. Scientists worry this could even threaten future space exploration missions, including planned trips to the Moon and Mars. Some regions of orbit already show debris density approaching levels that concern orbital dynamics specialists. Efforts are underway internationally to develop technology for actively removing debris from crowded orbital regions. Proposed solutions include robotic arms, nets, harpoons, and even powerful lasers to capture or redirect debris. The European Space Agency has funded missions specifically designed to capture and deorbit large pieces of debris. One proposed method uses a large net launched from a chaser spacecraft to physically capture tumbling debris objects. Another approach involves attaching a small thruster to dead satellites, guiding them toward controlled atmospheric re-entry. International agreements now encourage satellite operators to plan for safe deorbiting at the end of a mission's life. Many satellites are now designed with enough fuel reserved specifically to guide themselves into the atmosphere when retired. Objects in very low orbits naturally decay and burn up in the atmosphere within a few years due to atmospheric drag. However, debris in higher orbits can remain in space for hundreds or even thousands of years without intervention. This makes higher orbital altitudes especially concerning, since natural cleanup processes essentially do not exist there. Some experts believe humanity is approaching a critical decision point regarding sustainable use of Earth's orbital space. Without proactive debris management, future generations could inherit an orbital environment too dangerous for routine use. International cooperation and responsible satellite operation are considered essential to avoiding a catastrophic outcome. Donald Kessler's warning from decades ago now hangs over every new rocket launch, a reminder that the same technology lifting humanity toward the stars could someday seal us beneath a cage of our own making.